Hi, today I'll explain you the day 8 of this 30 days Verilog lecture series. Okay, so we completed with combinational circuits. Next, we are going to the sequential circuits. First, in the day 8, I'm going to explain about the SR latch as well as D latch. Okay, so the difference between latch and flip-flop is latch is level sensitive. Okay, either it may be positive level or negative level, and flip-flop is a edge triggered. Okay, during positive edge or negative edge. Okay, so here I will discuss about the latch, SR latch. Okay, set reset latch. So if you see this set reset latch, this is the Verilog code. I will execute in EDA playground, so AMD Vivado, Quartus Prime, and Model Sim. Okay. So this is the first of all I will explain you the code. After that I will execute in EDA Playground. So module, what is my module name? SR latch. So I am declaring input S, input R, output reg Q, and output reg Q bar. Okay. Q and Q bar I am using in the procedural block. Okay. This is a behavioral modeling style. So that's why I am using as a reg data type. Always at the rate, what are the sensitivity list S comma R begin if r equal to 1, okay, if r equal to 1, then begin q equal to and non-blocking with one tick binary 0, okay. So basically we'll design the SR latch by using NOR gate and SR latch by using NAND gate. So SR latch by using NOR gate is active high latch. So why we call that as active high latch? When r equal to 1, then it will go into reset state, okay. So q equal to 0 and q bar equal to 1. Else if when set equal to 1, then the next state value is 1. That means the state is set state. Okay. So when r equal to 1, the next state value is reset state. When s equal to 1 high, then the next state is a set state. So that's why we call this as a active high latch. Anyway, Q bar is a complement of Q and the end module. Okay. So I'm checking for reset and set. Okay. And coming to the test bench module, and my module name is test bench SR latch. I need to declare the variables. So reg S and reg R. These are the variables for the test bench. So wire Q and Q bar. So I need to instantiate my design SR latch. This design name and whatever I am instantiated in this test bench, this should match, followed by the instance name and I'm using connection by name. So whatever the variables outside the bracket are design inputs and outputs, and inside the bracket are test bench variables. Initial begin, and these are the uh, instructions for getting the waveform in EDA playground. Dollar dump file srlatch.vcd, dollar dump vars 0 comma test bench underscore sr underscore latch. Uh, so dollar display time srq and q bar. So dollar, so this is for displaying this and displaying the truth table. Okay. Dollar monitor means if there any change in the variable, then it will display. Okay. So that is time is percentage t and s is percentage b. In terms of binary, this is a format specifier. R is percentage b, q is percentage b, q bar is percentage b, comma. So how you define the time data type? Dollar time s comma r comma q and q bar. Okay. So I'm giving the stimulus text vectors driving the stimulus. So s equal to 0, r equal to 0. What is my output? S equal to 1 and r equal to 1. S equal to 0, r equal to 1. And s equal to 0, r equal to 0. So we already see in the truth table when s equal to 0, r equal to 0, that is, it will stay in the present state only. And when s equal to 1 and r equal to 1 means that is invalid state that I am not checking. So it will stay in the present state only. Okay. Dollar finish to end the simulation, dollar finish end and end module. Okay. So this I am seeing in the EDA playground. So once I open the EDA playground, so here I need to copy this code and go to EDA playground. So paste in this design and coming to the test bench, copy this code and paste in the EDA playground. and go to Tools and Simulator, select Aldec Rivera, and open EP waveform, save, and run. So I got the waveform. So here if you see when S equal to 0, R equal to 0, I'm getting like don't care. When S equal to 0, R equal to 0 and S equal to 1. Okay. So Q is set state. Q is what? Set state. And when S equal to 0 and R equal to 1, Q is reset. Okay. And when S equal to 0, R equal to this state, when S equal to 0, R equal to 0, it will stay in the previous state only. Okay. No change or latch state. So latch state means what is the previous state? 0 only. No. So it will stay in the 0 state only. Okay. And here I'm checking both are 1 1 means invalid state I'm getting. Okay. So both are S and R are 1 0 1 initially invalid state I'm getting. Okay. So you can see in this log file also. So initially don't care, and when S equal to 1 and R equal to 0, that is set state, and S equal to 0, R equal to 1, reset state, next state is 0, and S equal to 0, R equal to 0, that is latch state. Whatever the previous state is there, you are getting. Okay, you can see in the in this truth table also. Okay, and next coming to the Vivado file, project, new project, and create my project name. I'll just give the project name as what? Latches. Okay, latches. Okay, and choose the location where you want to store the your project. We are in day 8. Okay, and RTL project. Create the file name. Okay, so give the module name only. This is my module name. Copy this, and here you paste SR latch. Choose the location in day 8 latches. Select OK. Next, and next, finish. Yeah, my module name is also same. So in the SR latch, here you copy this code and paste here, save. So in the sequential circuits, we need to use the non-blocking assignments. Okay. So non-blocking assignment means both will execute parallelly. Okay. So whereas in combinational circuit, we need to use blocking assignments. Okay. So go to simulation, add the simulation source, create the file, and give the test bench module name. This is my test bench module name. Copy this, and here you paste, choose the location, latches, select OK, finish. OK. Yes. So here my test bench file is created. So go to this and copy this till end module. Copy this, and here you paste, save. So I want to see how the tool is converting my design into in terms of RTL netlist. So elaborate, go to RTL analysis and open the elaborate design. So like this, in terms of D flip-flop only, it is converted. Okay, two D flip-flops are there, but depending on an S and R, it will give the output Q and Q bar. Okay, when S equal to 0 and R equal to 1, so we are getting Q equal to 1 set state. when s equal to 1 and r equal to 0, when s equal to 0 and r equal to 1, we are getting the reset state. Okay, both are 0 0 means we are getting previous state, whatever may be the previous state. Okay, so next go to simulation, run behavioral simulation. So you can see in the TCL console also, see here. So whatever we seen in the log file, you got here. So when s equal to 1 and r equal to 0, q equal to 1. When s equal to 0, r equal to 1, q equal to 0, reset state. Again, when s equal to 0 and r equal to 0, so this is what reset state, sorry, latch state, memory state. It means whatever the previous state is there, you are getting that. Okay. So untitled, one second, you expand this, fit to page. Here you see. When s equal to 1 and r equal to 0, q equal to 1. Okay. You need to see this q only. When s equal to 0 and r equal to 1, that is reset state. Okay. Q is going to 0. And when s equal to 0 and r equal to 0, it is going into the latch state. So what is the previous state? 0, no? So it will stay in the 0 only. Okay. Like this we can see in the uh, Vivado, Vivado tool. Okay. Coming to the quarters prime. So new project wizard. Next, choose the location where you want to store the your project. So here in this 30 days Verilog, in the day 8, I want to store this sim folder. I'm selecting this folder. So I want to see the gate level netlist only, no? So I want to upload the RTL file. Okay. So here in the quarter file. So here in day 8, I created 3 folders. One is RTL, SIM and TB. Okay. So whatever the RTL related Verilog design files are there, I will store in RTL. Testbench files are there, I will store in TB. Okay. So this is my RTL file and empty project. Uh, one second. Here, this is my project name, SR Latch. Next and next. Here we need to upload the RTL file. Day 8 RTL SR Latch. Okay. Here I uploaded srlatch.v. Okay. Next, choose any FPGA family. Next, next, finish. So my RTL file is added. Go to analysis and synthesis, start. Yeah, I'm getting in this error. Okay, one second. Here I will copy this RTL file. Here, this is SR latch. One second. Yeah, this I will check. Next, coming to this model sim file, go um, to model sim SR latch. I need to check the waveform. Okay. So in the Vivado, we got the waveform. Same, I will check in the model sim. Go to project, uh, new project. Yes. And browse the project. The project location is date and sim folder. And the project name is latches. Okay. Add the existing files. Date RTL SR latch. Okay. and TB, TB file. Okay, close, right click, compile selected. I need to see the errors. Here in this code, errors are there. Okay, I'll check this. Okay. Next, we'll see for D-latch. Okay. So D-latch, if you see this program in the D-latch, so module D latch from SR latch you will get the D latch. Okay. So SR latch if you see like we have invalid case when S equal to 1 and R equal to 1 we have a invalid case. Okay. That we can overcome in the D latch. So when S and R are connected with an inverter then that becomes the D latch. Okay. So or transparent latch. So in D latch whatever the input is there that is coming to the next state that is qn plus 1 you are getting the state is what the we are giving the input as 0 you are getting the 0 and the input is 1 you are giving gated latch means we need to give an enable pin so that we can control the inputs okay level sensitive okay so here if you see this codes we'll see the code for the d latch here so day 8 this is d latch yeah here if you see the d latch. So module, what is my module name? D underscore latch. So input D, input enable, output reg Q. Okay. So this Q I am using in the procedural block. That's why I am initializing this Q and output Q bar. Okay. So I'm using, that means this is wide data type only. So this Q bar I'm not using in the procedural block. Separately, I'm assigning Q bar equal to not of Q always at the rate these are the inputs d comma enable begin if enable equal to like 1 then dq equal to d okay end module okay and coming to this test bench module and what is my module name test bench I need to declare the internal variables reg d and reg enable wire q and q bar I need to instantiate my design in the test bench so d underscore latch this design name this one should match and instance name is dut and this is connection by name okay so whatever the variables outside the bracket are design inputs and outputs inside the bracket are test bench variables so this is the initial begin and these are the instructions to execute in the edi playground dollar dump file d underscore latch dot vcd dollar dump vars 0 comma test bench underscore d underscore latch okay so dollar display, I want to display like in terms of truth table. First dollar display time D enable Q and Q bar. Dollar monitor is also a system task. If there any change in this variables, then it will display. Dollar time, okay. Percentage T. This is what time, okay. Percentage B. So these all will I need to execute in binary, okay. And these are dollar time D enable Q and Q bar, okay. So when enable equal to 1, so D equal to 1 after 10 time means I'm giving D equal to 0. Okay. So when enable equal to 1 only, this will be functional. Okay. This will act as a functional mode. When enable equal to 0, whatever may be the D input, it will stay in the latch state only. That we will verify in the simulation part. Dollar finish to terminate the simulation, we are using dollar finish end module. Okay. So this I will execute in the EDA playground. So if you see in the EDA playground, so just editor mode, copy this and paste here. So open the new playground, paste here and test bench also. Copy this and this paste. Tools and simulators, Altec Rivera, open EP after wave, save run after, run the code. So you'll get the waveform. See here, like when here if you see when d equal to 0, okay, radix is binary only. Yeah. Here if you see when enable equal to 1, d equal to 0, q equal to what? 0 only. When enable equal to, so here when here enable equal to 1, okay, and next here if you see enable equal to 0, d equal to 1, it will be in the previous state only. And here if you see enable equal to 0, d equal to 0, it will be previous state only. Here we need to check. That means in this case, here if you see, when enable equal to 1, d equal to 1, q equal to 1. Okay. So that means it is whatever the d input is there, you are getting at the q. And here also. So I need to check here. When enable equal to 1, d equal to 0, you are getting q equal to 0. Okay. So in this case, enable becomes 0. Okay. When enable becomes 0, whatever may be the d input, it will stay in the previous state only. So that is what d q equal to 0. Okay. Here also q equal to 0. Here enable equal to 0. So it will stay in the previous state only. Okay. So based on the truth table only, we are verifying. Okay. So here what happens when enable equal to 1, whatever the d input is there, that is coming to q. Okay. When enable equal to 0, it will stay in the previous state only. So q equal to 0 only you are getting. Okay. So this one I want to execute in Vivado. So close this. And here also close this. Go to design source. Create the design source. So create the file. So give the file name dlatch. Copy this and here you paste. Choose the location. Latches. Select OK. Finish. OK. Yes. This is dlatch. So here copy this and paste here. Save. So you want to see the circuit, need to right click set as top module and go to the test bench. So copy this and here we need to go to the simulation sources, add the simulation sources, create the simulation sources, give the test bench name, test bench underscore d underscore latch. No, so copy this and here we paste, choose the location. This is latch, select OK, finish. OK, yes, and test bench file is created. Here we need to copy this and here I'm pasting, save. So my design file, that is dlatch design file, that is dlatch, and is instantiated in the test bench, and this is instantiation. Okay, instance name. Okay, so for simulation also right click, you need to make a set as top module, and I want to see the circuit, how the circuit will be in terms of dlatch only it will give. So like this I'm getting in terms of D only. So enable is given to G and D and Q. So Q through the inverter Q bar and here this is Q. Okay. Run simulation, run behavioral simulation. So you can see in the TCL console also. So whatever we seen in the EDA playground log files, same thing you are getting. So that means here this is time D and enable. When enable equal to 1, D equal to 1, okay, you are getting Q equal to 1. When so enable equal to 1, Okay, D equal to 0, you are getting Q equal to 0. Okay. Here when second point, second bit, that is enable equal to 0, whatever may be the D input, you are getting what previous state. That is you are getting Q. Okay. So when the enable equal to 1 only, it will go into the functional mode. Okay. See here, when enable equal to 1, so D equal to 1, it is copying into Q. Okay. Here also, when enable equal to 1, D equal to 0, you are getting Q equal to 0. Here, when enable equal to 0, when D equal to 1, it will stay in the previous state only. So, what is the previous state value? 0 only, no? So, that is getting, okay, previous state only. When enable equal to 0, D equal to 0, it will stay in the previous state only, okay? So, like this, we can analyze in the EDA Vivado. Coming to quarters prime, file, new project wizard. I will close this. Okay, next. So, next you view this one. Yeah, I'll close this. This is D latch, no? So, one second. This is EDA playground. RTL, D latch. This is my D latch. So, give this project name, D underscore latch. Next, next, add the RTL file, D latch. So, my RTL file is added. Next, so any this one, and next, next, finish. Gated SR latch, we need to add the enable pin. Okay. So go to this analysis and synthesis, start. Yeah, I got 0 errors. Go to analysis and synthesis, expand this netlist viewer, right click, open RTL viewer. Okay, like this. So the tool is converting in terms of D latch only. Okay, and coming to the model sim, the file, project, new project. Yes, I want to. Project name, same, you give this D latch only. Copy this. Project name is D latch. Okay, and so browse is same only, sim folder. Okay, and add the existing files. So RTL, D latch. Okay, add the test bench files. TB testbench underscore D latch. Okay, close. Right click. Compile selected. Here also we are getting errors. Okay. Mm, there is a problem in the test bench. Need to check this. D latch design file is okay, but there is a problem in the test bench. Okay. SR latch. The D latch. Test bench underscore D latch. But in Vivado, it's you got the output, but model sim we are not getting. Test bench underscore compile. Yeah, I will check this and I will update.